Hi students, in this video I'll be going through the 2015 O-Level Additional Mathematics Paper 2 question 3. Alright, so this is a question regarding the equations of tangents and normals. Okay, so let's read the question. So they say that the equation of a curve is y equals to negative x squared plus 4x minus 6. So over here we have a quadratic curve. Okay, so the point P lies on the curve and has an x coordinate of 1, right? So the tangent to the curve at P, okay, will then meet the x-axis at A and the y-axis at B. Alright, so they want us for part 1 to find the area of the triangle AOB, where O is the origin. Right, so over here, let's do some backward thinking. Okay, so to find the area of a triangle AOB, we will need to know the coordinates of A and the coordinates of B. Okay, A lies on the x-axis, so we know that on the x-axis, what we can do is, if we know the equation of this tangent, okay, the tangent to the curve at P, right? Okay, all we need to do is sub y inside, and then we will get x coordinate. Then we will know the coordinates of A. And then likewise, to find the coordinates of B, B is on the y-axis, so we will sub x equals 0 into the equation of the tangent, and then we will be able to find the y coordinate of B. Okay, once we know the coordinates of A and B, then there should be no problem for us to find the area of the triangle AOB. O is the origin, that means O is 0, 0. Okay, okay, so now our first objective will be to find the equation of the tangent. Okay, so to find the equation of a line, we need to know two things, right? We need to know the coordinates of one of the points that the line passes through, and we need to know the gradient of that line. Okay, so both of these things we can actually find, it's not difficult for us to find. Okay, because you see that the point P lies on the curve and has an x coordinate of 1. Then the tangent to the curve at P. So that means the tangent and the curve will both pass through this point where the x coordinate is 1. So we can easily find the y coordinate of the point P by substituting 1 inside the equation of the curve. Alright, so that will be the first thing that we are going to do. Okay, so let's start our working. Okay, so y equals to negative x squared plus 4x minus 6. Okay, so when x equals to 1, okay, because the x coordinate is 1 of the point P, y is going to be negative 1 square plus 4 times 1 minus 6. Okay, so over here we will have negative 1 plus 4. Negative 1 plus 4, you will get 3, right? Okay, 3 minus 6, you will get negative 3. So now we know that both the curve and the tangent will pass through this point, negative 1, negative 3. Okay, so we can write down the tangent passes through 1, negative 3. Okay, so tangent passes through 1, negative 3. Okay, so the next thing we need to find out will be to find the gradient of the tangent, right? Okay, so to find the gradient of tangent, remember, what we can do is we can find dy dx, because dy dx is the gradient function of a curve. And then when we sub different values of x inside, we will be able to find the gradient of the tangents at different points on the curve. Alright, so what we're going to do is we're going to do dy dx. Okay, so this particular equation is very easy to differentiate, right? We'll get negative 2x plus 4. Okay, so we find dy dx. Then we are going to sub x equals to 1 inside, okay? Because we are finding the equation of the tangent at x equals to 1. When x equals to 1, dy over dx equals to negative 2 times 1 plus 4. So that will give us 2, right? Okay, so this means that the gradient of the tangent, okay, gradient of tangent at P will be equals to 2. Okay, so P is the point whereby x is equals to 1. Okay, so now we can find the equation of the tangent really. Okay, so we are going to use y minus y1 equals to m x minus x1 to find the equation of the tangent. So y minus y1, so y1 will be this one, right, negative 3. equals to m x minus x1. x1 will be this 1 over here. To get y plus 3 equals to 2x minus 2. Okay, so y will be equals to 2x minus 5. Right, so this will be the equation of the tangent. Okay, so once we know the equation of tangent, then we'll be able to find the coordinates of point A and B already. Okay, so if you refer back to the question, this tangent meets the x-axis at point A. So at x-axis, y is 0, right? Okay, so that's what we're going to do. Okay, let's do over here. The x-axis, okay, y equals to 0. So we're going to sub the y to be 0. So the equation of tangent is y equals to 2x minus 5, right? So now we're going to put 2x minus 5 equals to 0. Okay, so x will be 5 over 2 lah. Okay, so the point A will be 5 over 2, 0. Okay, then at the y-axis, now we want to find the coordinates of B, right? Okay, okay, x will be 0 now. So y equals to, okay, the equation is 2x minus 5, right? So 2 times 0 minus 5. So y will be negative 5. So the coordinates of B will be equals to 0, negative 5. Okay, so at this point, maybe we can do some sketching now, okay, to see how this scenario actually looks like. Okay, to visualize it better. Okay, so over here we have a quadratic curve, and we know that it's going to be a set face, right? Okay, so it's going to be a set face. Okay, so it's going to look something like this. Okay, then we know that the tangent is a positive one. That means tangent is going up. Okay, so this means that the point P has got to be somewhere around maybe here. Okay, so point P, and we know the coordinates is 1, negative 3. Right, so let me change the color of the pen to maybe blue. Okay, so the tangent is going to be something like this. Okay, so the tangent is going to be something like this. And this tangent is then going to cut the x and y axis at points A and B. Okay, so now we know that it should be something like this really. Okay, so we're going to draw the axis. So this is the point A. Okay, because A is 5 over 2, right? Okay, so over here will be 5 over 2, 0. And then here will be negative 5. So this will be the point B. This will be the point A. This is the origin. Okay, so now they want us to find the area of this triangle over here, like that. Find the area of this triangle. Okay, so that will be very easy because it's a right angle triangle, right? And then we can say that this base length, okay, this height over here, okay, will be 5, and this base will be 5 over 2. Okay, so area of triangle will just be half times base times height. Okay, so area of triangle AOB will be equals to half times the base, okay, 5 over 2 times the height, which is 5. Okay, so we'll get 6.25 units squared. Okay, so not too difficult, okay, of a question. Okay, I'm sure you can do it with some practice lah. Okay, so do try more questions like this. Okay, so let's go to part B of the question. Okay, so they say that the point Q also lies on the curve, and the normal to the curve at Q is parallel to the tangent to the curve at P. Okay, so let's redraw the diagram. So over here, okay, remember the tangent here is at this point P is 1, negative 3, right? And the tangent looks something like this. Okay, so the tangent look like this. Okay, so now they are saying that there's another point Q on the curve, right? The normal to the curve at Q is parallel to the tangent at P. So that means the point Q has got to be somewhere here. Okay, why somewhere here? Because now is the normal. Because the normal at Q, right, is parallel to the tangent here, no? Okay, so remember that this equation of tangent is y equals to 2x minus 5, right? Right? So if this normal over here, this one is the normal, okay, is parallel to this line. So we know that when lines are parallel, they have the same gradient, right? So the gradient here is 2. So that means the gradient of this normal is also equals to 2, right? So they want us to find the coordinates of Q. So how can we find the coordinates of Q? Okay, so remember, dy dx gives us the gradient function, right? Gradient function is the gradient of the tangent at different points on the curve, depending on what points you sub inside the dy dx, right? Okay, so if the gradient of normal is 2, okay, so one question I would like to ask is, can you find out the gradient of the tangent easier? So the tangent will be over here, right? Yeah, and this normal and tangent will be 90 degrees to each other. So if I know the gradient of normal is 2, I can find the gradient of the tangent easily, correct? Okay, once I find the gradient of tangent, all I need to do is to equate this equation of the tangent, this value over here, to the dy dx, and then I solve for the x, I'll be able to get the x coordinate of q. Once I get the x coordinate of q, I sub it back into the equation of the curve, then I'll be able to get the y coordinate, and I solve the question already. Okay, so this will be the approach that I'm going to take. Okay, so let's start off with the working. So we know that the gradient of the normal is at q is equals to 2 already, because it's parallel to the tangent at p, which has a gradient of 2. Okay, so let's calculate the gradient of the tangent. Okay, so we know that when two lines are perpendicular, the product of their gradients is -1, right? So the gradient of tangent at q, so this one is at q, okay, gradient of tangent times gradient of normal will give us -1. So the gradient of the normal is 2 over here. So multiply, get -1. Then gradient of tangent would be -half. Okay, so if gradient of tangent is -half, we can equate dy dx to half. So dy dx will be equals to -half. Okay, so remember dy dx is now dy dx was -2x plus 4, right? So now we are going to equate -2x plus 4 to -half. Okay, so -2x, okay, bring the 4 over, minus 9 over 2. So x will be 9 over 4. Okay, so once we get x value, we sub the x value back into the equation of the curve. Okay, -x² plus 4x minus 6. So y will be -x². So now x is 9 over 4 plus 4x minus 6. Okay, so that will actually give you a -33 over 16. Okay, or if you write in decimal, it will be -2.0625. Right, so we can conclude therefore q equals to 9 over 4 and -33 over 16. Okay, so this is the answer over here. Right, so you can see that such questions are actually not difficult. You just need to understand the concept behind it, and then you should be able to handle anything that they ask you. All right, so do more practice, and you will get more confident. Okay, the moment you get more and more answers correct, then you will become more confident already. Right.